Guys, hope all of us are doing fine. My name is Ernest, and this is Ernest Sciences and Mathematics TV channel. In this particular discussion, I'm going to look at a type of measures of dispersion. And of course, this is going to complement on the previous ones that we have discussed on the concept of a range and, of course, the concept of a relative range. And of course, we have already talked about some other aspects of types of dispersions, such as the quartile deviation and the coefficient of a quartile deviation. Now, in this case, we're going to look at the concept of the mean. And in our previous discussion, I had basically mentioned that we can compute the various aspects of means in terms of the arithmetic, the geometric, and of course, I talked about the concept of the harmonic mean. And in some of our discussion, I had mentioned, of course, the concept of a weighted mean in that particular case. So we're going to rely on this specific aspect of the arithmetic mean in trying to define the concept of the mean deviation, which is going to be, of course, describing the arithmetic mean of values of absolute deviation of a given type of average. Now, in this case, if we have a specific type of distribution whereby its average has been given as these specific values for the mean, we're going to find the deviation of this specific average by finding the difference between this specific distribution and the mean given as such. Now, the absolute value of this specific quantity is going to be given as such. So therefore, this is going to constitute the mean, and this is going to be the absolute value of the deviation from the mean given as such. So in this case, in case I measured the deviation from the mean, basically it's going to be algebraically representing this specific concept of xi minus the mean given as such. So therefore, the concept of the mean deviation, as I've said, is going to be an arithmetic mean of values of absolute deviation from a given type of average. And this is going to depend on the various types of averages, which is going to be or an average which is going to be used from the various measures of central tendency, which are mentioned for the mean, median, etc. Now, in this case, we can discuss one of them, which is basically the concept of the mean deviation about the mean deviation about the mean. So I'd say that basically this is going to be the arithmetic mean of a particular of course, the arithmetic mean of various or values of a specific or absolute deviation from a given average. Now, in this case, we're going to consider our average to be the mean and try to find the deviation. Now, from this particular case, then therefore, we can compute this concept of the mean deviation about the mean. And this is going to be given in terms of a notation of the mean deviation about the mean given as such. So this is going to be a value of the summation between I is equivalent to 1 to n. And in this case, we're going to consider the group and ungroup data as we have been doing for various other aspects of measures of central tendency. So therefore, I'm going to consider this specific group data, which is going to be given in terms of xi observations minus the mean given as such. So we're going to find the absolute value, the summation of the absolute values of this difference between, or the division of these specific values from the mean, and then we're going to divide this one by the number of observations given as such. So in case we are given a frequency distribution that constitute, of course, the classes perhaps which are mentioned, we can give a second variation of this mean deviation about the mean given in terms of the summation between I is equivalent to 1 to the number of classes given as such. And this is going to be given as the difference between that specific observation, of course, given as xi minus the mean. And all of this is going to be divided by the number of observations given as such. So this is going to be given for ungroup data, and this is going to be given for a frequency distribution as I've mentioned. Now, there are specific steps which you are going to, of course, employ in trying to find this specific aspect of the mean deviation about the mean, which, of course, are going to be involving first for us to evaluate the arithmetic mean, which I've given in terms of this specific value. And then secondly, we're going to find individual values for the deviations which are going to constitute the xi minus x, of course, minus the mean given as such. And this is going to give us, of course, the specific values of these specific readings for the deviations of each reading from the mean given as such. And of course, we're going to evaluate this specific mean about the mean by ignoring this specific, of course, sign. And this is going to be the absolute value which I've basically given. So we're going to find this the sum of absolute value of these specific deviations, and then we're going to divide it by the number of observations which I've given at the lower part. So this is going to be a simple procedure for us in trying to find the various aspects of the mean deviation about the mean. Now, in our subsequent video, I'm going to give a specific example which is going to give us a general case for the mean deviation for various aspects of averages, and that's going to of course complement on these particular videos for making us understand the whole concept of this specific deviation for this average that we have used in a particular video. So that's it for now, guys. Kindly check our description boxes for various other videos which are going to be as topics of a similar discussion, and they're going to be, of course, complementing on these various discussions that we do, especially on the application part. So that is it for now, guys. Bye, God bless you. Catch us in our next video.